We now discuss the solution of a problem from the section three-dimensional geometry. This problem is on the rotation of a given plane. This question has appeared in the joint entrance examination main held on 26th June 2022 in the second shift. The given question is, if the plane 2x plus y minus 5z is equal to 0 is rotated about its line of intersection with the plane 3x minus y plus 4z minus 7 is equal to 0 by an angle pi by 2, then the plane after rotation passes through the point. We are given four options. Option A, the point with coordinates 2, minus 2, 0. Option B, minus 2, 2, 0. Option C, 1, 0, 2. Option D, minus 1, 0, minus 2. We are given two planes. The first plane is 2x plus y minus 5z is equal to 0. The second plane is 3x minus y plus 4z minus 7 is equal to 0. And this plane, the first plane 2x plus y minus 5z is equal to 0, is rotated about the line of intersection of this plane with the second plane by an angle pi by 2. Then the rotated plane passes through one of the following 4 points. We have to find out that point through which that plane after rotation passes through. That is our given question. Let's now discuss the solution of the problem in detail. Let us call the first plane as P1 and the second plane as P2. So P1 is the plane given by 2x plus y minus 5z is equal to 0. P2 is given by 3x minus y plus 4z minus 7 is equal to 0. Then the family of planes passing through the line of intersection of the planes. So take the planes P1 and P2, take its line of intersection. Then there will be infinitely many planes passing through the line of intersection of these two planes. That is why it is called the family. The family of planes passing through the line of intersection of these planes P1 and P2 is given by P1 plus lambda times P2 is equal to 0, where lambda is a parameter. That is P1. So that is given by, so this is, the illustration is here. The red one is P1 and this one, green one, is P2. They are intersecting. This is the line of intersection. Through the line of intersection, there will be many planes passing through it. And one of them is shown with the blue color. And that family is given by P1 plus lambda times P2 is equal to 0. P1 is 2x plus y minus 5z plus lambda times 3x minus y plus 4z minus 7 is equal to 0. Simplifying, we get 2 plus 3 lambda multiplied by x plus 1 minus lambda multiplied by y plus minus 5 plus 4 lambda z minus 7 lambda is equal to 0. Let's call this as the equation 1. So the family is given by this 2 plus 3 lambda times x plus 1 minus lambda times y plus minus 5 plus 4 lambda times z minus 7 lambda is equal to 0. Let's call this family as 1. Why this? How this will represent a family? Lambda is a parameter. As the lambda takes different real values, then you will get different planes and you will get infinitely many planes, and that is the family of planes passing through line of intersection of P1 and P2. Now, what is to be done? Let P be the plane obtained by rotating P1 about the line of intersection with P2 by an angle pi by 2. So P1 is rotated by an angle pi by 2. So P is the plane obtained by rotating P1 about the line of intersection with P2 by an angle pi by 2. So this green one is the plane pi. Agreed. So how do you get it? That is, the plane P is a member of the above family. The family is given by 1 for some lambda. That lambda we have to find. So how do we get P? By rotating P1 by an angle pi by 2 about the line of intersection with the plane P2. So this P1 and one of the member of the family 1, they are orthogonal. Therefore, using the orthogonality condition, 2 plus 3 lambda multiplied by 2, these are direction ratios, plus 1 minus lambda multiplied by 1 plus minus 5 plus 4 lambda multiplied by minus 5 is equal to 0. We now continue in the next slide. So that's what we have done so far. Simplifying this one, we will get 30 minus 15 lambda is equal to 0. That will give rise to lambda is equal to 2. So now put lambda is equal to 2 in the family given by 1. Then if you substitute lambda is equal to 2, that is 2 plus 3 times 2, that is 6 plus 2, 8 lambda. 1 minus 2 y, that is minus y, plus minus 5, 2 4s are 8, 8 minus 5, 3z, minus 7 into 2, that is 14. So we get this one. That is one of this family is obtained by rotating P1 by an angle pi by 2 about the line of intersection of these two planes. Agreed. So this is the plane P is given by 8x minus y plus 3z minus 14 is equal to 0 is a plane obtained by rotating P1 through a right angle about its line of intersection with the plane P2. Agreed. Now the plane P passes through the point. So you check these options one by one. So P passes through one of these points. You have to check one by one. Suppose you check option A, 2 minus 2, 0. So you substitute 2 8s are 16 minus y minus of minus 2, that is 16 plus 2, that is 18, and 3z is 0. 18 minus 14 is not 0, therefore it is not satisfied. So likewise you go on checking the options. We find 1 0 2, that is x is 1, 8, y is 0, z is 2. So 8 plus 2 3s are 6, 8 plus 6, 14, minus 14, that is equal to 0. So it satisfies this equation. Therefore the answer to this question is option C. That is, the plane P, that is the rotated plane P, passes through the point given by option C. So our answer is option C. And that is the detailed discussion of the solution of the problem on the rotation of a plane from the three-dimensional geometry. It is moderately difficult question. It's not easy. Definitely, you should know what is a family, how it will work, and what is the orthogonality condition, and all these things you have to apply. Then you will get the answer. So anyway, so that is the detailed discussion of that one. I am sure that you have understood the solution of this problem. I wish you all the best. Thank you.